Hello, welcome to SPMM Revision on Demand. In this podcast, I will discuss two important graphs associated with economic analysis. Firstly, let us revisit the concept of ICER. ICER, or Incremental Cost Effectiveness Ratio, is nothing but a ratio between incremental cost and incremental effectiveness. The word increment means difference. So if you divide the cost difference between two interventions by the effectiveness difference, you can get ICER. The value of ICER indicates the additional cost, usually in pounds, required to be spent to achieve one additional unit of gain in the clinical outcome that is being considered. What value of ICER is ideal? In other words, on the basis of ICER, when will you consider a treatment option to be cost effective? To answer this question, we must look at a figure called cost effectiveness plane. This helps us to visualize the additional cost required per additional unit of improvement in a two-dimensional space. The y-axis of this plane represents incremental cost. As you move up the y-axis, more money is being spent on the intervention being considered. As you move down, less money is spent, resulting in cost savings. The x-axis represents incremental benefit. As you move rightwards on the x-axis, more beneficial effects are obtained from the intervention being considered. As you move leftwards, less amount of benefits are notable. The ICER value estimated for any new intervention can fall into one of the four quadrants. If it falls on the southeast quadrant, then the new treatment is certainly cost effective, as it is not only more effective but also requires less investment. If it falls on the northwest quadrant, then the new treatment is certainly not cost effective, as it not only requires a lot of investment but also has less beneficial effects. The two quadrants, southwest and northeast, are areas of uncertainty. When a treatment has ICER values falling in northeast, it indicates that a considerable investment is required to realize the potential gain in effectiveness. If it falls on the southwest, it means that considerable savings can be made only if we accept some loss of clinical benefit. These trade-offs may or may not be acceptable, depending on how much money is available for investment. In other words, whether a treatment with ICER in areas of uncertainty is acceptably cost-effective or not actually depends on the decision maker's willingness to pay. Let us assume that your hospital is willing to spend up to £20,000 in order to achieve a gain of 1 QALY among depressed patients. This is shown by a point that corresponds to the values 20,000 in y-axis and 1 QALY in x-axis. A line connecting the point of intersection of the x and y-axis and the willingness to pay threshold can now help us to reduce the uncertainty. The area below this line is called a zone of acceptable cost effectiveness. This area can increase or decrease depending on the willingness to pay threshold. If the ICER for any new treatment falls below this willingness to pay threshold line, then we can consider this intervention to be acceptably cost effective. I hope by now it is clear that the probability that a treatment is acceptably cost effective depends on the willingness to pay threshold. As you can see here in this figure, the ICER values for a number of hypothetical treatments are plotted. A good number of these treatments have acceptable ICERs falling under the black line, which depicts the willingness to pay threshold of $50,000 per quality. When you increase the willingness to pay threshold to $65,000 per quality, the number of ICER values that become acceptably cost-effective increases. But if the threshold is lowered to $30,000 per quality, then the number drops. So, if we know a decision maker's acceptable ceiling of willingness to pay, we can then estimate probability that a given intervention will become cost effective. In other words, for any given budget, we can calculate the uncertainty around the estimates of cost effectiveness using a cost effectiveness plane. This is a bit similar to the estimate of confidence intervals in parametric statistics. CEAC stands for Cost Effectiveness Acceptability Curve. This is another way of presenting the uncertainty around the acceptability of cost effectiveness. As discussed earlier, each value of willingness to pay gives a specific probability of cost effectiveness. If we plot various WTP, that is, willingness to pay values, along the x-axis, and the cost effectiveness probabilities along the y-axis, we can get a cost effectiveness acceptability curve, CEAC. Please note that the WTP metric could use any measure of effectiveness, for example, number of depression-free days or QALYs, etc. CEAC has several potential uses. It shows the maximum level of probability or confidence that can be reached by increasing investments in a healthcare project. It also shows the level of investment above which not much gain in confidence would occur. This is the plateau point. This lies somewhere between 40,000 and 60,000 in the graph shown here. 40,000 and 60,000. Finally, we can also visually assess the confidence that a measure would remain cost-effective across different affordability settings. Let me now show you a CEAC graph that came up in a recent exam. You can see that there are three CEAC curves depicted here. One for tricyclics, shown by a continuous line, one for SSRIs, shown by a dashed line, and one for lofipramide, shown by a dotted line. Overall, it appears that the SSRIs have a higher probability of being cost-effective under various thresholds of willingness to pay. The maximum threshold reached in terms of probability is around 0.65. The maximum is nearly reached at an investment level of £15,000 per quality. Further investments do not bring much more remarkable gains. Though SSRIs appear to have higher probability of being cost-effective compared to the other two antidepressants, below a certain point, corresponding to around £5,000 per quality, SSRIs lose their supremacy. Now, it is time to ask yourself a few questions. Thank you for choosing SPMM course for your revision.